everyone, my name is Alex and welcome to an Engineer's Findings. This episode is sort of an overview of my EMCO V13 lathe here. I want to share with you some of my thoughts on its original design, some experiences. I want to show you the most important modifications I did to it and the most important accessories I've gathered over the years for it. So this lathe was made in 1988 by EMCO in Hallein, Austria. Hallein is a city close to Salzburg, for those of you guys interested in the geography of Central Europe, I guess. The first owner of this lathe was a gentleman from Vienna. He operated a machine shop in, believe it or not, downtown Vienna. A machine shop that made custom length pneumatic cylinders. But he closed his business in 2009, which was when I bought this lathe from him. Funny story, his machine shop was located very close to Schloss Belvedere, which is the place where the Austrian peace contract was signed in the 50s. So good for us. I believe I was particularly lucky with this machine buy because to my best knowledge, this machine is the most expensive variant which EMCO made of the V13 lathe. It has the largest bed length option, it has the optional hardened bedways, the optional 2-speed motor and the optional electric brake. So I think that's a really neat combination. I have the price list from EMCO from 1988, and this machine, the base machine, so without the DRO, without all the modifications I did, without the scraping work, and without the accessories, the base price for this machine was 135,000 Austrian shillings back in the day. And when I use the tool from the Austrian National Bank to translate this price to 2024 euros, this would be roughly 25,000 euros base price translated to modern days. So I don't know if this is a value that could stand nowadays, but yeah, it's up for you to judge. So this lathe has served me very well over the years. I have introduced some important modifications to it, like the Heidenhain DRO, the central lubrication system, the thread pitch indicator, and some other minor stuff. So I will not part with this lathe in the near future. And so, in case you're interested in these things, join me, why not? So something that is quite interesting on the EMCO V13 lathe is its lathe bed. And with interesting, I mean the EMCO lathes of that era had an interesting bed slide geometry. So the bed slide rides on this surface, this one here and this one here. And on this prismatic bed slide we have a rather interesting angle combination of 30 degrees towards the vertical and 25 degrees towards the horizontal. So a 95 degree included angle on this prismatic guide here. And more typical with other lathes or other manufacturers is the 45 degree combination that we also have here on the tailstock. So I don't know if this was a branding or a trademark item for EMCO, or if it was rather some limitation with the grinding machine they used to make these beds. I really couldn't tell, I don't know. Because this prismatic guide has an annoying consequence, I would say. So you see this surface as a consequence of those angles is quite small, this one being much larger. And when you think of cutting action, the cutting forces acting on the tool are mostly pointing downward, but we also have secondary cutting forces in that direction and that direction. Now this one here is no problem because this is countered with the rack and pinion combination that moves the bed slide, but this force here, which can be rather large, just think of parting work or form cutting work with large engagements when you have to use quite some force on the cross slide. This force here bears rather exclusively on this surface here. And this surface being so small causes then more wear to accumulate on this surface than on the other surfaces. So this is something that can be annoying on EMCO lathe beds if they have accumulated some wear, because then the bed slide moves like this in the horizontal plane, which can be a problem when you have very tight tolerances on cylindrical surfaces. Something I also have a difficult time to understand is why they chose this particular angle of those ribs here. If you wanted to make the bed rigid against bending in the horizontal plane due to forces like this, you would rather arrange these ribs in a 45-degree fashion, I would say. But this one is kind of strange to me. But then on the other hand, I must say I rather prefer the box type ribs. For example, Weiler uses those because to my engineering understanding, those box type ribs are better in terms of rigidity, overall rigidity for the lathe bed in contrast to these ribs here. But still, I must say, I cannot complain about the stiffness of the bed because I don't have too much issues with chatter. Of course, every lathe sooner or later chatters. It's just a question of overhang, tool engagement length, cutting forces, and so on. But this lathe behaves rather well in terms of vibration. So I could not complain, is what I'm trying to say. In my opinion, one feature of the V13's original bed design was not really well thought of. And what I mean by that is the location of its bed slide travel end stops. So this pin here, that was originally in that hole, and I moved it further to the left. And this second pin here. So they hit a protrusion in the casting of the bed slide and thereby limit its travel. And this original position here was totally fine whenever you are using the chuck. However, with the collet arrangement, you had to extend the compound slide a fair bit when you had short workpieces in the collet to be able to reach everything. So, because there was no danger of hitting anything else, I moved this pin 30 mm to the left, and thereby I can use more of the bed travel. And check out this here. So the variable end stop in the fully retracted position, I can reach this one now. I couldn't reach this before. And with the compound slide in its mid position, you see with standard tooling I'm quite close to the opening of the collet, which is good. But you know, with a chamfering tool like this one here and short workpieces, you already have to use the compound rest to be able to reach this. So absolute necessary modification in my opinion when you're frequently using the collet arrangement. As far as lubrication of the V13 is concerned, I'm really happy with this part and this part, but not so much with the rest. So maybe this didn't receive a lot of designer love, or maybe it was neglect. I really don't know. Originally, the lathe had quite a limited amount of oiling ports. So there were 2 ports for the bed slide, one here and one here. And I'm particularly unhappy with those 2 because this one was only a hole down to the bed slide and one very short pocket. And that was supposed to supply oil to the whole bed slide, which it didn't do. I modified this in the meantime, but that's a story for another time. You may be able to tell I modified this lathe with central lubrication. You can tell from the piston distributors here. There are also distributors hidden here, 6 of them. And I have also central lubrication now here on those bearing points. But that's a story for another time that I hope to be able to show to you soon. There were originally oiling ports, those 2 for the bed slide, and they were really rudimentary in terms of routing oil to the slide surfaces. There was one original oiling port here, one here. there were no oiling ports for the sliding surfaces. The instructions just said to oil them from the outside regularly, and you know how well that can be done. The tailstock had only one original oiling port, which was here, and the coil was intended to be oiled just from the outside, which is, yeah, you know, you can only do it so well. The sliding surface of the tailstock had no oiling ports whatsoever, so this is also something that I really dislike, and I added all of these oiling distributors to take care of that. These 3 bearing points up here particularly, they had no oiling ports whatsoever. Now they did use sinter bronze bearings, which in some point in the manual are called, I believe, lifetime lubricated, but you know, how long is lifetime? And we can always improve on that. So that's the reason why I added this central lubrication mod here on these points. A modification that I did quite early on this lathe was this door here, because it annoyed me so much to change gears. You had to remove 1, 2, 3 bolts, take off this whole cover, then the main power would go out because of that micro switch that protected that cover, this micro switch here. So you take off the sheet metal cover, then this micro switch depresses, and so with the micro switch closed, the main power is on, but whenever you take off the cover, the main power falls off. You lost reference with the DRO. Of course, that's no big problem because you have to walk your slides over the reference points again, but still it's an added annoyance. Of course, you could say, but Alex, don't be stupid, don't wire the DRO into the mains of the lathe, just have a separate switch to switch on the DRO, but I think that's not a good practice. So what I came up with is this door here. So whenever I change gears, I don't lose main power, I don't lose reference, and I don't have to hassle with this cover and with these 3 bolts. It's just, you know, it's simple, you know. This lever here is dampened with an O-ring so that it would not vibrate open. Also, if you have an eye for details, this hatch only touches the original cover in this section here. Everything else has a gap, a machined gap. So whenever this lock is down and wedges onto that bolt here, this door does not rattle and it does not create any added noise. The part is just an aluminum sheet metal part that I bent on the press brake, and I had some Cherry Max countersunk rivets and some hinges to keep all of this together. So every second saved is a second earned. The safety guys among you now, of course, they may say, Alex, this cover is not protected and somebody could switch on the lathe while you have your fingers in there and you could get your fingers smashed and so on. Yes, true, possibly, but keep in mind, I have no untrained employees. I'm the only person operating this lathe, so who cares? I don't. So in order to be able to show you some details, some interesting details on the spindle head of the machine, down here we have the main motor and brake assembly or combination that drives this pulley V-belt, drives the input shaft. On the main gearbox we have a basic 4-gear selector lever, which you can see moves this selector gear in the gearbox, and then we also have this final drive selector which moves this final drive gear here and lets it either mesh with that gear or with the spline on the inside. But I don't want to delve too much into that main gearbox thing because I never had any issues with the main spindle bearings, the main spindle or the gearbox itself, so that's totally fine.
The only thing that comes to mind whenever I think of the main gearbox that is a bit strange is that there is some notable play on this output shaft that drives the change gears of the lead screw gearbox. So I'm not sure what's going on here. I've never had any leakages here or in general on this lathe. Still, I'm a bit confused where this is coming from. Next time I change the oil in the main gearbox, I will also disassemble this section here just for curiosity in order to investigate what's going on here and where this play is coming from. So here's the main spindle feed through. I think the diameter is 36 millimeters. So you could say for that size lathe it could be a little larger, and be that as it may, but you know, with the longer lathes and large stuff that is long, you usually use the steady rest on the bed instead of tunneling everything into the main spindle. But that's a matter of taste, so whatever. So the collet draw tube on this machine, of course that was an optional accessory. Originally it did not have these 3 holes here, which I later machined into it, and I guess you were supposed to tighten this just hand tight, but this is not a safe thing to do because then the holding power on the collets is quite little. So what I did was I machined these holes that have a tight tolerance fit on the standard chuck key for this machine, and you can see this is then how you can put some leverage onto the collets when you tighten them. Of course, we don't want to tighten the collets like crazy, but I want to tighten them more than just the hand gripping power here. So on the spindle side, when we are using the collet arrangement, something that I realized quite quickly is that I need to make this particular bolt here. This is a lightweight aluminum bolt with aluminum nut that secures the cam lock ring of the spindle flange. So whenever you're using a chuck, then this cam lock ring is closed and tightened, but when you're using the collet arrangement, this ring is loose. And when you're using high spindle speed, then whenever you start or stop the spindle, this ring smashes backward and forward, and it just hurts in the sole. So I made this bolt here as lightweight as possible to introduce only as little imbalance as possible, and that one secures this ring. There are some people who make a complete ring with 3 studs and 3 nuts on the backside to secure this ring, but that is 2 more nuts to tighten than this one, and that's very simple. And I never noted any influence of the imbalance of this on the work, so that's fine. When I bought the lathe, I only got 3 or 4 collets with it, but I watched the used market quite closely, and I was lucky enough to find a complete set for a very good price. Now, even though those collets are packed in EMCO packages, what they are is they are Swiss-made Schaublin collets, and I think they were just repacked in EMCO boxes. And they're B32 size. Now, that may not be much use, because if you order them directly from Schaublin in Switzerland, then last time I checked, I think the price for one collet was north of 100 euros. So not a cheap option, but I was lucky enough to find a complete set for these. So the lead screw gearbox is really fine on this lathe. I never had any problems whatsoever. I must even say on this lead screw here, which has this quick coupler, so usually it's static whenever you have it off, and then when you push in the quick coupler, it's coupled to the gearbox. I must say I never even shared the share pin in here, so either the share pin is size too large per design, or it is intended that it can only be broken with brute force. But never ever happened to me. I'm glad about that. So that's good. As far as the thread pitches are concerned, this lathe is the metric combination. It was also sold in Imperial, with Imperial lead screw. But all the standard metric pitches, they're easy peasy, don't have to change gears, just set the levers in their respective positions and off you go. The imperial pitches I have to use quite regularly, I must say. In order to be able to cut imperial pitches, we have to at least change this gear combination into the drive here. So that's the 120 to 127 combination that jets us from the metric into the imperial world, transatlantic. And usually we also have to change this and probably this gear here additionally to come up with the imperial pitch that we desire. So I don't have all these additional gears. For example, I don't have the 50 tooth count gear, but still I can count these pitches. So, but how do you do that, you might say? Over the years, I have made a few change gears for this lathe that allow me to cut NPT thread pitches on top of those here. And NPT 1/8, for example, has a thread pitch of 27 TPI. And from this table, you can see there is no 27. So even with the original configuration of that lathe and all the additional change gears, you could not cut NPT 1/8. But I can do that because I have change gears with, I believe, 76 tooth count and 92. Those not only allow me to cut NPT thread pitches, but also they allow me to cut, for example, these combinations here. So that's why I never even bothered making a 50 tooth count gear. So I think here's the 30, 65, 70. I think those are standard pitches. 75 is also standard. Then I have the 76, which is dedicated NPT, which was not original tooth count. And I have the 90. 92 is also not original tooth count. So these, all of those are custom made ones, but those two I mentioned, they allow me also to cut NPT pitches 110 and 120. You can hit the pause button and transfer those additional pitches, which I can cut with those non-original gears. Among them are, for example, NPT pitches. So this is sort of a modification workaround that I came up with. It was probably 10 years ago when I did the DRO upgrade to this lathe. So I invested in some top-notch Heidenhain components for this. And this display here, for example, is an ND780, I believe. So there's absolutely no question about Heidenhain quality. I never had any problems with it whatsoever. As far as precision is concerned, I really trust that company. However, there are three little bummers on this display which continually keep annoying me. And one thing is that whenever it's colder in the shop, like today, the display needs a little time to develop its full contrast, a minute or two. Then the other thing that is just, I think, not necessary, you have to push a button to get past this Heidenhain display. So how many button pushes is that in a lifetime? And let me just drive it past the reference points. So whenever I go to the tool store, you can see this is tool number 8, number 16, and then when I push further down, it's back to 1. So for some reason, they limited the amount of tool stores to 16, which is a little few in my opinion. But other than that, I'm really happy with this upgrade. So the linear scale, I also put a linear scale on the compound rest. I had to install this cast iron shim on top of the compound rest in order to allow for the size of the Heidenhain linear scales. It would have been nice, in fact, if EMCO had used a little more thickness on the compound rest here per design, because when you gronk down really hard on this bolt here, then you can feel the compound rest slide get a little tighter. So this obviously deforms the top of the compound rest a little. On the back here I made this custom cast iron bracket as a holder for the linear scale, and I designed it in a fashion that it looks like the other components up here, so that it doesn't look so obviously like a modification. The linear scale on the cross slide only needed these machine cast iron shims and some machine flat spots on the bed slide down here for the slider. Other than that, it was quite easy. The linear scale on the bed is a larger cross section because of the high length and the spaces available back here. So here I had a machine surface which I used for mounting the linear scale, and on the other side of the bed I didn't have a machine surface and I didn't want to machine this spot here, so what I made was a leveling pad with 3 set screws. This leveling pad can be adjusted to be exactly parallel with the bed and coplanar with the left surface in order not to deform this linear scale when you tighten it. This wood piece on top, my dad made this for me, and it's a deflector so that chips don't collect on top here, and it's worked ever since. So I drive the slider of this linear scale with this sheet metal piece here that's mounted to the bed slide. There's a few little modifications on the bed slide, which 2 of them have their dedicated YouTube videos. Quite recently I made these rubber way wipers here, and a little more time ago I made this threading dial indicator which works for metric and imperial thread cutting. So quite a convenient addition to the lathe, I must say. Then a few years ago I re-scraped the cross slide on this machine, not to the full extent. The coplanar surfaces were fine, but I re-scraped these tilted sliding surfaces because the right angle error between the cross slide and the bed slide was, I believe, 20 microns over the whole travel length. So I improved upon that.
Some people get really confused when they see my machines raised off the ground with makeshift stuff like these wooden blocks here. And I get it. But it gets even worse. My machines are not anchored to the ground either. It's only that these blocks, they are bolted to the machine base. So what's up with that? Now think of how many hours you spend in course of a year in front of your machine. Now add those hours together and you might get weeks of your life. You might get even months of your life. And I want to spend those weeks standing in an upright fashion. And necessary for this is that the stuff we touch the most on our machines with our hands, being the hand wheels here for example, is roughly at elbow height. And take a look. That's good. That's not so good, but it's not so bad either. Think of these 2 wheels being 15 centimeters closer to the ground. That would require me to stand weeks of my life during a year in a bent over fashion. And I don't want to do that. And it's not for the reason you think. Now some people might object, but Alex, your lathe will vibrate a lot because of this. It really doesn't. And I use a lot of cutting pressure with the parting tools, with form cutting tools. I really don't see it. Then some other guys might object, but Alex, with heavy eccentric stuff in the chuck, your lathe might really heavily vibrate on you. It might even tip over and stuff like this. Possibly, but you know what? I think it's really bad practice to use heavy eccentric stuff without counterweights and without pre-balancing it, so I really don't do that. Also, I have no untrained employees who would do that, so it's really of no concern of mine.
So which chucks do I use? Mostly I use those 2 here. So this is the original 160mm diameter EMCO 3-jaw chuck that came with the lathe. It's my standard go-to solution if I don't use the collets, because I have a good selection of jaws for it. Aluminum soft jaws, steel soft jaws, outside and inside jaws. So this is a good all-round solution. It's also nice to use a smaller chuck on the lathe, in my opinion, unless you need a larger one, because this adds way less inertia to the spindle than a big chuck, and this is more gentle on the drivetrain and more gentle on the brake of the lathe. So these are the additional jaws that I have for the EMCO 160mm diameter chuck. I have these steel soft jaws. These are dedicated for a returning customer job, so I don't use these every day. Then the hardened outside jaws, and these I like a lot. These are custom made aluminum soft jaws that I use. So what I did was I ordered soft jaws for the EMCO chuck and machined those with the tight tolerance pocket features and drilled and tapped them for the fine threads to accept these more modern and standardized aluminum soft jaw tops. These are more easy to turn and more easy to deburr than the steel soft jaws, so I favor those over those. And I think they provide absolutely adequate holding power. And what I also like is those are wider than the aluminum soft jaws. So whenever you have something really thin-walled or flexible, then these are better for a clamping solution than the steel soft jaws. And in order to have those carriers more durable and give those a longer life, I send it out for surface hardening. And I was afraid that the fit of those carriers would be messed up due to the hardening treatment, the fit in the body of the chuck. But the nitriding solution, sorry, I meant nitriding. The nitriding solution turned out with no problems of fit of these jaws in the chuck body. So this worked out very well, I must say. Quite soon after I bought the lathe, I got this 200mm diameter Bison 4-jaw independent chuck, and I wouldn't want to miss a 4-jaw independent on a lathe because it's the go-to solution if you have something large that has to have a real good run out. In my opinion, or my practice is, I'm faster with chucking with a 4-jaw independent than turning soft jaws, so I wouldn't want to miss this. Also, if you have something that has rough surface, like a housing of something, a cast housing that you have to repair or return, this is the go-to solution in my opinion. From the estate of my late friend Albert Klocka, I also have this 4-jaw chuck that I reconditioned to keep it as a memento of him. And I use this whenever I have something really large. This has this has funny story, but 230mm diameter. I don't know why they chose that number, but it is what it is. So whenever this is too small, I still have this one. And I also use this when I have square stock to start from. And this recent find, this new old stock 200mm diameter EMCO 3-jaw chuck, I still have to make a flange for it, but I want to make a flange that is fine adjustable in order to be able to adjust the run out of this one, but I still have to attack this flange problem yet. The tool post I use on this lathe is an original EMCO system or EMCO accessory. And this was installed on the lathe when I bought it, and the first owner also sold me, I believe, 4 tool holders. Much too few, of course, but still. And although you cannot source new tool holders for this system from the market anymore, I still want to stick with it. Because one advantage of this system, in my opinion, is that it's very easy to check the registering surfaces for cleanliness and to clean them before you insert the tool holder and clamp down on it. If you compare this with, for example, the multi-fix system, on the lather it's much more easy to mess up and clamp down on a chip and lose repeatability that way. The only thing that is a bit annoying is the fact that for loosening and tightening the tool holders you always have to grab a spanner. So that's one more move of the hand, repeated many times during a lifetime, but still it doesn't annoy me so much that I want to change to a different system, a system that has just one lever operation. Over the years I made 2 batches of additional tool holders, so I ended up with this assortment here. And this one here is an original EMCO, for example. Most of the other ones are from my production. And for the second batch, Stefan Gotteswinter ground those prism surfaces for me. And they're all carbon nitride for good wear-resistant surface quality. About the tools themselves that I use, I must say I try to stick with as few different carbide insert types as possible. So that's the reason why I have, for example, this funny looking boring bar with that tiny CCGT06 insert, but this boring bar uses the same insert like this boring bar. So in my opinion, it's very easy to waste a lot of money by having too many different carbide insert types, and I try to limit those as much as possible to the most common ones, I must say. You also see that I grind a few tools myself. Usually I grind them out of solid carbide stock on the D-bit grinder, like this grooving tool here, for example, or this special grooving and chamfering tool that I use for shortening bolts. But other than that, I think it's a pretty standard assortment of cutting tools. An accessory that I can really recommend for both the lathe and the mill are these rotor broaches or core drills. If you need large through holes through workpieces, these are so economical because firstly, you're so quick drilling out a slug of material from a raw piece of stock, and secondly, you can save on the slug, and you know, with that size, that's quite some material that you save that way. You save labor and you save material. Now, of course, these are not cheap. They cost, I don't know, this one maybe in the area of 100 euros, that one particular. And I buy the Carnage brand, but I'm not sure if that is available in the US and not just a European thing. But you may have something similar. I only buy the carbide tipped tools anymore. I had a few high-speed steel versions earlier to test this, but if I buy something new, I buy only the carbide tipped ones. In order to use these in the lathe, I have this Morse Taper 3 to cylinder shank holder that fits these cutters. And for the large ones, I use those in the mill, but for lathe work, I have to make a dedicated tool holder that fits the tool post, because I have a bit of a headache when I think of using these large core drills on the Morse Taper 3 shank. That doesn't seem right. On the accessories side, I wanted to show to you this quite expensive, I must admit, but very, very useful pliers here. It is a Knipex electrical plier. And what makes it so useful for lathe work is that it has a quite pointy tip and a large distance between the hinge and the tip of the jaws. So with a small opening on the handle, the jaw opens quite some distance, and in combination with the pointy shape of the jaws, it's really nice to catch chips during machining, particularly when you're quite close to the chuck or to the collet. So a really nice addition to any lathe, I think. Much better than any chip hook. The chip hooks are a nightmare, in my opinion. Another thing that is really convenient and useful is this life center here. This life center is made by ATORN in Germany. It is a Morse Taper 3 life center, and what makes it so useful is this big conical section, because when you have large holes you can still use this. and it is stepped from the small tip, and this step makes it really versatile because your cutting tool is usually not in the way when you're starting on the workpiece.
So I hope this video contains the one or the other useful thing for you. Thanks a lot for sticking with me until the end of this video, and I'll see you on the next one. Bye!